Check 1 2. It is September 17th, 2022, and this is tutorial 3, using values from other studies in your code. In tutorial 1, just as a quick recap, we learned how to create a study, how to compile it using the remote compiler, how to create inputs, how to spit stuff out to the debug log. In tutorial 2, we covered subgraphs. We wrote a cool little study calculating the number of highs and lows in a session. And here in tutorial 3, we're going to cover how to grab and use values from other studies that are in your chart, or maybe even another chart, and how to use them in your code. So a pretty useful thing that a lot of folks have been asking for. Over here, I don't trade the ES, but we do have the ES up here. It is a 1-minute candlestick chart of the ES, pretty basic Sierra chart functionality. And what we're going to do is we're going to go to the analysis, studies, and we're going to add true range, and we're going to add average true range. We're going to add 2 studies. I'm just going to use the default input settings on those. So up here in this subgraph area, right here, this is subgraph area 2, this is subgraph area 3, and this is subgraph area 1, which is the original price chart. In this area, we have the true range of each bar, each 1-minute bar on the ES. And so you can see, for example, this bar here was 7.2825 points, most likely. And then this is the average true range. So it's the average over 14 bars of a simple moving average of these numbers here. And what we're going to do in this code here is set up a study that reads the values of this study, crunches some numbers from those values, and then spits out something else. And the utility here isn't what we're going to build so much, but for you to see and then be able to write your own code referencing your own studies or other studies to calculate values that are meaningful and useful for you. And that's where the benefit of this comes in. So first thing that we want to do is to see that we have a template here, and it's all standard stuff that we covered in tutorial 1. We got the Sierra chart .h header file, we got our DLL name, we've got our main function, and we have our little logging object because I'm probably going to screw something up and need to debug stuff. Here's our defaults code block. This is where we're going to set defaults like the name of the study and what region it's going to default in, and that's all that we have here. So we're really starting off from scratch. And first thing we need to do is we need a way to actually reference these 2 studies, because we want to be able to pick them on our input and be able to use that to identify exactly which studies we want to grab values from. So the first thing we need to do is actually set up some inputs. So I'm going to make a little section here above our default area code block here, and I'm just going to call this area inputs. And the first one, we can say SC input reference, and I like to just put an I underscore before them so I can easily identify it as an input. This is going to be our true range input, and it's going to be sc.input 0. And I'm going to make another one, and it's going to be called average true range, and this is going to be input 1. Okay, and then inside of our defaults section, we want to say iTrueRange.name equals select true range study. And then we probably want to do the same thing for average true range, select average true range study. And then the next thing we want to do is for the true range input, we want to say set chart study values. And what this function does is it tells Sierra chart to create, let me show you actually I'll show you right here. It'll create, well, this has no inputs, but let's use this one, which does have inputs. It'll tell it to create an input here that you can click on and then select another study on the chart. So what we're going to do, the first argument that this takes is actually the chart number. So I think it's sc.chart number is the current chart number, which is also chart number 1. We're on chart number 1 right here. I can see it up here. Also see it right there. Chart number 1 is a 1-minute ES. But if you say sc.chart number, you don't need to hard code 1 in here. You can just reference whatever chart that this study is running on, which will be the same chart. So yes, that means you could potentially grab studies from other charts, not just the one that you're running the study on, which we're going to get into later. So I'm going to, for now, say sc.chart number to reference the current chart, and then I am going to put a 0. And the reason I'm going to put a 0 is because I don't want to hard code in what the ID of this or this study are. I want to be able to use the selector that we're going to have pop up on the screen to show that. So I'm going to do a similar thing down here. I'm going to say I_ATR set chart study values. I'm also going to set it to 0. So now we have 2 inputs that are both going to be drop-down lists of studies that exist on this chart that we can select. And you know what, before we even go on, let's go ahead and compile this. So I'm going to go to Analysis. I'm going to say Build Custom DLL. I'm going to say Select Files, Tutorial 3, Build, Remote Build. We're going to see it go ahead and compile here. Give it a second. Remote build succeeded. Excellent. Let's go ahead and go to Analysis, Studies. Let me just move this off the screen a little bit so that it's not in our way. And then I'm going to go ahead to Add Custom Study, and I'm going to find Tutorial 3. There it is. Tutorial 3, using values from other studies. That comes from this line right here. And then Tutorial 3 comes from this line right here. So I'm going to click Tutorial 3. I'm going to hit Add. And what do we see? Select True Range Study. Select True Range Study. Select Average True Range Study. Select Average True Range Study. Chart number 1, which is pre-populated because we use sc.chart number, and this study was added to chart number 1, thus it presets chart number 1 here. But if you had other charts in the chart book, you would see them in this drop down. You could select them, and then here in this one we have a drop down of all the studies. We have the main price graph, the true range study, the average true range study. This first input right here is asking us to grab the true range study. That's ID number 1. And then this one right here is asking us to grab the average true range study, which is ID number 2 right here. So now you can see I have chart 1, ID 1, chart 1, ID 2, and OK. And I hit OK. And Tutorial 3, there's my study, my custom study I'm writing here. I'm going to hit OK. And you can see it's right there, and it has absolutely nothing on it. And that's because we are doing absolutely nothing with it other than adding those 2 inputs and selecting those 2 studies. So we have gotten those 2 studies as references to them. We now know what they are called. And the next thing we need to do is actually find and build out how to access the values that are coming in from here. Okay, and from there, what we need to do is come into this block underneath this default code block, and we need to actually declare a variable to hold the array of information, or rather values, I should say, from each of the 2 studies. So the way we do that is using an scFloat array object. And the reason is because all the values that are stored in here are in this time series, and they are stored as floats. So even though, well, no, these are floats. These aren't integers. Well, some of them are integers, but they're stored as floats in Sierra chart. So scFloat array, and we'll call this first one the true range reference, and then the second one we'll call the average true range reference. And what we want to do with each one of them is pass these in by value, or by reference, sorry. Pass these in by reference to populate these arrays with the study values. Now, if that doesn't make sense, you'll see what I mean in a second here as we use a practical example. There's a function that we're going to call, and it's going to be called sc get study array using ID. And in this, it takes 3 parameters. The first one is the ID of the study, which, if you recall, we got from this input and this input. So the first thing we need to do is say itr dot get study ID. That's the first argument of this. The next argument is going to be which subgraph of this study. So let's look at the true range one. Which subgraph do we want to grab? Let's open up the settings for true range. We'll go to the subgraph. There's only one subgraph in here. And by the way, there's actually another input type, set chart study values. I forget what it's called, but you can look in the documentation. Maybe we'll find it later. It allows you to actually select not only the chart and the study, but the subgraph itself too. So you have a triple picker instead of a double picker. So like instead of just this and this, there's a third drop down for inside the whatever study you selected. It lists all the different subgraphs, so you can collect those as well. But right now we're going to use this one, and we're going to just look at the true range. And in the true range, there's only one subgraph, and it says SG1, but this is a zero-based index list. So subgraph 1 is actually index 0. So we're going to say 0 for the second argument because that's the subgraph. And then the third argument is actually the sc float array that we want to pass in by reference to this function. And what that's going to do, trref, what it's going to do is it's going to take this currently empty array, trref, this float array, it's going to go to the study ID, subgraph 0, and take all the values that are in there and store them into trref, which we will then use locally here in this file. So we're going to do the same thing for atr, and we're going to store it into atref. And let's just sanity check this going to atr. Let's look how many subgraphs there are. There's only one on there as well. So now that we've done that, we have all the information from true range for every single piece of time here stored into trref, and we have every single data point from average true range indicator stored inside atrref. So that's really neat. Let's go ahead and do a sanity check on if this actually worked. We're going to use our message object here, this logging object, and we're going to say message.format, and we're going to say the last tr is equal to a float, and the last atr is equal to this float. And what we're going to say is trref sc.index, and then we're going to say atrref sc.index. And what this is doing is creating a string, create a string that displays the current index being which bar we're on the time scale on the x-axis, and it's going to be the last one because this code's going to run for everything and then get to the end, and that's what we're going to see as the value. So we're going to see the last value of each of these two arrays. So what I expect to be spat out in our debug log is going to be something like 8 for the true range, and then something like 4.21 or 8.25 for the true range, and then 4.25. We should see these exact values actually be spat out because we're referencing them directly. All we need to do is sc.add message to log, and then we'll pass in message, pass in 1, and then let's go ahead and bring this over, build, remote build. Let's see if this compiles. And it does. I'm going to take it off the screen, and I'm just going to hit refresh. And okay, over here on my other screen, we got 2 pieces of debug. And let's see, the first one, oh, this must be from the very first bar that was calculated on the graph. And then the second one is the very last one. 8.25 is the true range, which is the current true range right there. 8.25 corresponds to 8.25, which corresponds to trref sc.index. That's the last index that the Sierra chart calculated. And that's what's being spat out here for tr equals 8.25, and then atr is being referenced from the ATR ref, and that should be 4.25, which it is 4.25. So our sanity check is valid. We are seeing those values come over. And if you wanted to do something like only show or only calculate the most recent one, what you could do is you could put an if block like this. If sc.index is equal to sc.array size minus 1, and we can just go ahead and add these debug prints into, which is saying only execute this code when we're on the very last bar, and then let's see if that just gives us the final value there. Let's have this remote build, and let's go ahead and rerun, and oh, it's right there. It's right there. Yeah. Let's see if it reran. Yep, there it is. Okay, great. So that's exactly what we would expect for that situation. If you only wanted it to be on the very first bar on the chart, so going all the way back to whatever this date is, then you could do something like if sc index equals 0. Or if you wanted to loop through everything, you could create a for loop or some other kind of loop and loop through every single index and then have it calculate and spit out every single index's value. So, but those are different use cases than what we wanted to look at here today. So now we have access to every single data point in both of these studies. So what? Now what do we do? Well, now we can add our own logic to do our own calculations on that data. And what would be an interesting thing is to answer the question of when is the true range greater than the average true range? That could be interesting. When is the true range greater than the average true range? Let's go ahead and do this way. Let's go ahead and loop through every bar that is visible on the chart. So to do that, we're going to make a for loop called for integer I is equal to sc dot, oh gosh, what is the name of it? I think it's like first visible index. I might be wrong on that. We might have to go back. So what it'll do is the Sierra chart compiler will find the index of the first visible bar here. So let's say this is bar 500, and then we can use the last visible bar, and it'll only calculate what we see on the screen. And while I is less than sc.last visible index, I++. So we'll just start from the first and go to the last. And I might be wrong about these, so if we get a compiler error, I'll have to look this up. But I don't memorize that kind of stuff. I just Google it when I need to. So we're going to be iterating through, and I will represent each bar index in between what we see on the left side and what we see on the right side. And then what we can do is grab these debug lines out of here, and instead of fetching sc.index, we're going to fetch I, which is going to be representative of the index that we're currently iterating through. So it's going to spit out every single, and actually let's say I is equal to and we'll put I right here. So now our debug is going to spit out which index we're on, and then whatever the true range and average true range values are at each bar index from the ones that we see on the screen. So let's go ahead and do that as we build this up. Compile. Oh, we got errors. First visible index. Yeah, I must have gotten the names on those wrong. First. Oh, I see. Okay. It's not first visible index. It's called index of first visible bar. And then this one's called index of last visible bar. So those are the proper names for those two properties. So let's go ahead and recompile it with those changes. And now we should not get anything screaming at us from the compiler, which we don't. Go ahead and move this off the screen. I'm going to go ahead and clear the log here. Yep. And then I'm going to just go ahead and hit rerun. And look at that. So we have 7,023 bars being rendered on the chart. I know that because the final one, we're at the end of the chart, and the final one is 7023. And we see the true range and the average true range values for these two subgraphs, for these two studies rather, I should say, for each of those bars. And so now what I'm wondering is, okay, so we're ripping through that. When is the true range actually larger than the average true range? So let's add a conditional in here. This one right here. So this is loop through visible bars on screen. And this is when is the true range greater than. So let's add an if trref I is greater than atrref I, then go ahead and spit out this debug. So we're not going to get it for every bar anymore. We're only going to get it when the true range value at the index that we're looping through. So we're going to start here, right? We're going to start here. So this one is 4.34 or whatever. And then this value here is 3.3. And it's going to say is 4.3, whatever that was, 4.34 greater than 3.3? No, it's not. Okay, go to the next one. Is 2.91 greater than 3.3? No, it's not. But then it's going to eventually get to a point like here. I'm just looking visually. And it's going to say, is 6.59 greater than 3.5? Well, yes, it is. It is. And so it's going to pass this conditional as truthy. It's going to go into here, and then it's going to spit out saying that, hey, on this index, this condition was satisfied. So let's go ahead and do that. Build, remote build. And then we'll take that off the screen, and then I'm just going to hit redo here, and now we see that we're not going every single bar. We're actually skipping indices. So starting at the very last one, if I move this over here, we can see it spiked up. It spiked up here pretty high on the true range. So true range was 5 on the last one, but no, true range is 8.25. What the heck happened? Well, that doesn't make any sense. 4.67, these aren't even the right numbers. Why does it think that true range of 8.25 is not greater than 4.22? Let's go ahead and clear this log. That doesn't make any sense. And then let's go ahead and rerun this. Interesting. And I thought that the last number was actually 7023, but this is 7019. So 7019 has 5 and this is 4. Let's take a look. Did we do something wrong? So starting here, oh, I see the error. It's right here. The error is right here. So what our for loop is doing is it's saying, okay, start off on the first visible bar index, so it is starting here on this very first one, but go up until we are less than the last index. In other words, it will never execute on the last index because we have a less than sign here. What we need is a less than or equal to sign right there. So that's just a programmer error on my part. So you're getting to see the rust of me not having coded in a couple weeks showing there. So I went ahead and added an equal sign, and then let's try to see what it looks like now. And now, there we go. There's that last one, 7024, 8.25. That's this right here. And then 4.25, that's right there. And we can see that in each of these instances, so 7024, then 7019, 5 is greater than 4.6, 7015, 7.25 is greater than 4.8, and then here, so on and so forth. So we can see that we're identifying spots that it's only greater. So you know what would be really cool is if we could somehow add a visual cue. Like, it's great having it in the debug log, but let's add a visual cue of some sort. We learned how to do this in tutorial 2, adding a subgraph. What if we made a point every spot that had a true range that was greater than the average true range? So in order to do that, we need to go ahead and add a subgraph here, and we'll call it SC subgraph. Gosh, I don't even remember if this is the correct way to do it. I believe it is, but I don't remember off the top of my head. I think it's SC subgraph ref. And I'll call it S TR comparison equals sc.subgraph 0. And we'll have to give it a name. str comparison is equal, or .name is equal to our true range comparison. And we're going to need to recompile, and we're actually going to need to remove tutorial 3 from this chart in order to add a subgraph to it. It won't work if we just recompile it without removing. Whenever you change something that's in the defaults block, you need to actually remove the study from the chart and then re-add it, going through analysis and all that. But either way, we have sc.tr comparison. And then what we can do now is, when we have this situation, we can say str comparison for I is equal to, and then we can put a value here. And what we could put for the value is actually anything we want. We could make it be true. Actually, no, we can't make it be anything we want. It has to be a float of some sort. We can make it be 1. Just saying, yes, it does happen here, no, it doesn't. Or what's more interesting, we could actually make it a calculation of these two numbers compared to each other. We could say, to what degree is TR, the true range, greater than the ATR at this point? So let's go ahead and do that. Let's say TR ref I divided by ATR ref I. Okay, and we're going to cast this whole thing as a float, just to make sure that that gets stored properly in there. So let's go ahead. We're going to actually remove tutorial 3. We're going to recompile and hopefully get a successful build here remotely. We did. Then we're going to go to analysis. We need to re-add the study, remember? Add custom study. There's tutorial 3. We're going to add it. And then let's see, there's our subgraph. Okay, there's the subgraph we added just now. Right here, TR comparison and true range comparison. That's why it's there. We didn't specify a line style or draw style. You know what we can do? We can make this a point, just in like a big point. And let's just hit OK and see what happens here. Let's see what happens. And we have nothing. We have nothing happening here. And I wonder why. Oh, I see why. Look at this. We forgot to select our inputs. So we need to reselect true range for that one. And then on this one, we need to reselect average true range. Now let's hit OK. Aha. So all of these points that you're seeing are us adding to our internal subgraph the places where the true range is actually greater than the average true range. And so what you're starting to see here is while some of these places are up high, like this one here is almost 2 times greater, some of them are on the lower side, only 1.07 times greater, so barely greater than the other one. So this is pretty interesting as you go back. And since we're not getting, this is a Saturday and the market is not active, we don't see this as we scroll backwards because we're going off of index, visible indices. So we actually need to recalculate these. And so I just hit recalculate, and now you can see, look at this one. This one's over 2 times greater than the average true range at that point in time. So this becomes really interesting. You could potentially look for something that's more than 2 times, or you could make this only spit out when it's 2 times greater or 3 times greater. You could even create an input to say, only show me the whatever the input specifies, number of times greater than what true range is greater than ATR. The options are really limitless for what you could do with this type of thing. But I think that's a good place to stop. We're already at over 30 minutes. So what we've done here, just as a recap of everything, we have gone ahead and specified 2 inputs. One of them is to grab a study that we added called true range, but you can make it whatever study you want. We added a second one called average true range, which we selected the average true range. And then what we did was we created a subgraph so we could put our own calculations onto the chart. And what we did was we went ahead and grabbed the values from those 2 studies that we referenced, and we put them into these arrays here. And then we were able to loop through our chart and look for some kind of condition or criteria happening between these 2 studies, and then actually plot our own third study based off of that. So there's a lot of stuff that you could do based off of this type of idea, and this is really just an example for a demonstration, but you can see where you could go from this. So hopefully that helps, and I'll try to post this basic code up here into the description of the video, and let me know if you have any follow-up questions. I'll try to help when I have time. Have a good weekend.